Class 10, Subject Science, CBSE Syllabus, NCERT Books, Lesson number 2, Chapter 2, Acids, Bases and Salts. Page number 1. You have learnt in your previous classes that the sour and bitter taste of food are due to acids and bases, respectively present in them. If someone in the family is suffering from acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar, or baking soda situations. 1. Which property did you think of while choosing the remedy? Surely you must have used your knowledge about the ability of acids and bases to nullify each other's effect. 2. Recall how we tested sour and bitter substances without testing them. You already know that acids are sour in taste and change the color of blue litmus to red, whereas bases are bitter and change the color of the lead litmus to blue. Litmus is a natural indicator. Turmeric is another such indicator. Have you noticed that a stain of curry on a white cloth becomes reddish brown when soap, which is basic in nature, is scrubbed on it? It turns yellow again when the cloth is washed with plenty of water. You can also use synthetic indicator such as methyl orange and phenolphthalein to test for acids and bases. In this chapter, we will study the reactions of acids and bases, how acids and bases cancel out each other's effect, and many more interesting things that we use and see in our day-to-day life. Do you know? Litmus night solution is a purple dye which is extracted from lychine, a plant belonging to the division Thallophyta, and is commonly used as an indicator. When the litmus solution is neither acidic nor basic, its color is purple. There are many other natural materials like red cabbage leaves, turmeric, colored petals of some flower such as hydrangea, petunia, and geranium, which indicate the presence of acid or base in a solution. These are called acid-base indicator or sometimes simply indicators. Page number 18. Question. Number 1. You have been provided with the 3 test tubes. One of them contains distilled water and the other 2 contain an acidic solution and a basic solution respectively. If you are given only red litmus paper, how will you identify the content of each test tube? 2.1. Understanding the chemical properties of acids and bases. 2.1.1 Acids and bases in the laboratory. Activity 2.1 Collect the following solution from the science laboratory: hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3, acetic acid CH3COOH, sodium hydroxide NaOH, calcium hydroxide CaOH twice, potassium hydroxide KOH, magnesium hydroxide MgOH twice, and ammonium hydroxide NH4OH. Put a drop of each of the above solution on watch glass one by one and taste with a drop of the indicators shown in table 2.1. What change the color did you observe with red litmus, blue litmus, phenolphthalein and methyl orange solution for each of the solutions taken? Tabulate your observation in table 2.1. Table 2.1. A table is given with the column sample solution, red litmus solution, blue litmus solution, phenolphthalein solution, methyl orange solution. You have to fill this table. These indicators tells us whether a substance is acidic or basic by change in color. There are some substances whose odor changes in acidic or basic media. These are called olfactory indicators. Let us try out some of these indicators. Activity 2.2. Take some finely chopped onion in a plastic bag along with some strips of clean cloth. Tie up the bag tightly and leave overnight in the fridge. The cloth strips can now be used to test for acids and bases. Take two of these cloth strips and check their color. Keep them on a clean surface and put a few drops of dilute HCl solution on one strip and a few drops of dilute NaOH solution on the other. Page number 19. Rinse both cloth strip and water and again check their odor. Note your observation. Now take some dilute vanilla essence and clove oil and check their odor. Take some dilute HCl solution in one test tube and dilute NaOH solution in another. Add a few drops of dilute vanilla essence to both test tube and shake well. Check the odor once again and record changes in odor if any. Similarly, test the change in the odor of clove oil with dilute HCl and dilute NaOH solution and record your observations. Which of these, vanilla, onion and clove, can be used as olfactory indicator on the basis of your observations? Let's do some more activities to understand the chemical properties of acids and bases. 2.1.2. How do acids and bases react with metals? Activity 2.3. Question. This activity needs the teacher's assistance. Set the apparatus as shown in figure 2.1. Second, take about 5 ml of dilute sulfuric acid in a test tube and add a few pieces of zinc granules to it. Third, what do you observe on the surface of zinc granule? Fourth, pass the gas being evolved through the soap solutions. Fifth, why are bubbles formed in the soap solution? 6. Take a burning candle near a gas-filled bubble. 4. What do you observe? 5th. Repeat this activity some more acid like HCl, HNO3 and CH3COOH. Are the observations in all the cases the same or different? In figure 2.1, it is shown that reaction of zinc granule with dilute sulfuric acid and testing hydrogen gas by burning. Page number 20. Note that the metal in the above reactions displaces hydrogen atoms from the acids as hydrogen gas and forms a compound called a salt. Thus, the reaction of a metal with an acid can be summarized as acid plus metal is equal to salt plus hydrogen gas. Can you know? Write the equation for the reaction you have observed. Activity 2.4. Place a few pieces of granulated zinc metal in a test tube. Add 2 ml of sodium hydroxide solution and warm the contents of the test tube. Repeat the rest of the steps as in Activity 2.3 and record your observations. The reaction that takes place can be written as follows. Twice NaOH plus Zn is equal to Na2ZnO2 plus H2, that is sodium zincate. You find again that hydrogen is formed in the reaction. However, such reactions are not possible with all metals. 2.1.3. How do metal carbonates and metal hydrogen carbonates react with acids? Activity 2.5. Take two test tubes, label them as A and B. Take about 0.5 gram of sodium carbonate Na2CO3 in test tube A and about 0.5 gram of sodium hydrogen carbonate NaHCO3 in test tube B. Add about 2 ml of dilute HCl to both the test tubes. What do you observe? Pass the gas produced in each case through lime water, calcium hydroxide solution as shown in figure 2.2 and record your observations. In figure 2.2, it is shown that passing carbon dioxide gas through calcium hydroxide solution. The reactions occurring in the above activity are written as test tube A Na2CO3 plus twice HCl is equal to twice NaCl plus H2O plus CO2. Test tube B NaHCO3 plus HCl twice NaCl plus H2O plus CO2. On passing the carbon dioxide gas evolved through lime water, CaOH2 plus CO2 is equal to CaCO3 plus H2O. Page number 21. On passing excess carbon dioxide, the following reaction takes place. CaCO3 plus H2O plus CO2 is equal to CaHCO3 2 soluble in water. Limestone, chalk and marble are different forms of calcium carbonate. All metal carbonates and hydrogen carbonate react with acids to give a corresponding salt, carbon dioxide and water. Thus, the reaction can be summarized as metal carbonate or metal hydrogen carbonate plus acid is equal to salt plus carbon dioxide plus water. 2.1.4. How do acids and bases react with each other? Activity 2.6. Take about 2 ml of dilute NaOH solution in a test tube and add 2 drops of phenolphthalein solution. What is the color of the solution? Add dilute HCl solution to the above solution drop by drop. Is there any color change for the reaction mixture? Why did the color of phenolphthalein change after the addition of an acid? Now add a few drops of NaOH to the above mixture. Does the pink color of phenolphthalein reappear? Why do you think this has happened? In the above activity, we have observed that the effect of a base is nullified by an acid and vice versa. The reaction taking place is written as NaOH plus HCl, NaCl plus H2O. The reaction between an acid and a base to give a salt and water is known as neutralization reaction. In general, a neutralization reaction can be written as base plus acid is equal to salt plus water. 2.1.5. Reaction of metallic oxide with acids. Activity 2.7. Take a small amount of copper oxide in a beaker and add dilute hydrochloric acid slowly while stirring. Note the color of the solution. What has happened to the copper oxide? You will notice that the color of the solution becomes blue-green and the copper oxide dissolves. The blue-green color of the solution is due to the formation of copper 2 chloride in the reaction. The general reaction between a metal oxide and an acid can be written as metal oxide plus acid is equal to salt plus water.